Forget flags and footprints. The new space race is already here, and trust me, it's being fought at a level you can't even see, the atomic level. Today, we're going to dive deep into how this incredible fusion of artificial intelligence and revolutionary new materials is unlocking a whole new chapter for humanity in space. Let's get right into it.
Okay, so here's the game plan. First, we'll get into why space is just so darn hard, the core challenges that have held us back for decades. Then, we'll look at the game-changing solution that AI and advanced materials are bringing to the table. From there, we'll map out the booming new market this is creating, see how it's actually helping us back here on Earth, and finally, we'll take a peek at what's coming up on the next frontier.
All right, first things first, we have to appreciate just how difficult this all is. You know, getting to space is one thing, but surviving there, that is a whole different ballgame. It is without a doubt one of the most hostile environments you could ever try to engineer for, and that reality has shaped everything about space exploration for more than 50 years.
And this quote right here, it just hits the nail on the head. The core problem isn't just about building bigger rockets. It starts way smaller, at the atomic level. The stuff we've traditionally built spacecraft out of just can't take the punishment space dishes out. They get brittle, they degrade, they fail. And that barrier, that materials science wall, has been the main thing holding back our biggest ambitions.
So you see, it's not just one big problem. It's really three massive headaches all at once. You've got the brutal physics of just being in space, the crippling economics of getting anything off the ground, and a very modern problem: we are getting buried in more data from space than we know what to do with. To win this new space race, you have to solve all three. Let's just start with the physics. A satellite just floating in orbit goes through this absolutely punishing temperature swing. It goes from nearly absolute zero when it's in a shadow to scorching hot in the sun. Just try to imagine designing a material that has to work perfectly across a 420 degrees Celsius range, over and over and over again, without failing. And here is that modern bottleneck I was talking about. Our eyes in the sky, our sensors, are getting exponentially better. They're generating 100 times more data than they used to. But our ability to download that data? It's like we've built a fire hose of information, but we're trying to drink it through a tiny coffee straw. We're drowning in data we can't even get back home.
And this number? Well, this is the harsh economic reality of it all. Even with launch costs coming down, it is still wildly expensive to put anything in orbit. We're talking over $2,500 per kilogram. That means every single gram is agonized over. Weight isn't just a design detail. It is the single biggest economic factor in all of spacecraft engineering.
So, you've got this three-headed monster of a problem, right? How in the world do you solve it? Well, the answer lies in this incredible synergy, this powerful team-up between artificial intelligence and the design of these amazing multifunctional nanomaterials. This, right here, is where the game completely changes.
You can really see the massive shift here. The old way of finding new materials was, well, slow. It was painstaking trial and error in a lab, limited by what a scientist could guess or imagine. AI just flips the script completely. It runs millions of virtual experiments inside a computer, predicting how materials will behave and finding the best combinations for multiple goals at once. It's exploring a whole universe of possibilities humans could never get to.
So what does that process actually look like? Well, it's pretty slick. First, engineers just put in their wish list. You know, we need something super strong, lightweight, and that can handle radiation. Then the AI gets to work, using machine learning to predict how millions of different atomic combinations might perform. Next, it optimizes, finding the absolute best trade-offs. And only then, at the very end, do scientists go into the lab to actually create and test the best couple of options. It's a total shift from discovery to design.
So what are these magical materials the AI is dreaming up? They're called multifunctional nanomaterials. And honestly, the best way to think about them is like a Swiss Army knife. By engineering things like graphene at the atomic level, you can create a single, incredibly light material that does the job of 3 or 4 different old-school ones. It's your structure, your thermal control, and your radiation shield, all rolled into one.
And look, this isn't science fiction. These breakthroughs are real, and the numbers are amazing. We're seeing materials that conduct heat better than some metals, magnetic alloys that are 50% tougher against radiation, and these things called graphene aerogels that are so light, they're basically solid smoke. These are the literal building blocks for the next generation of everything we send to space.
Now, all this amazing tech isn't just happening in a vacuum. It's creating a brand new economy, a whole new market. So let's switch gears and start mapping this thing out. Who are the players? What are the key parts? And where are the big opportunities for investors and innovators?
And if you want a sense of the scale here, just look at one single niche component: in-gas image sensors. These are critical for a lot of space imaging. That one little market, all by itself, is projected to be worth $1.7 billion. It just shows you the incredible value that's being created at every single step of this new space supply chain.
And that growth is not a fluke. You see it across the board. The market for another key part, photodiode sensors, is on track to double in less than a decade. And what's fueling all this? It's that relentless demand for more and better data from orbit. That's the engine driving this entire new space economy.
Naturally, when you have that much growth, the innovators and the disruptors are going to show up. And we're seeing this new wave of dynamic startups challenging the old guard. You've got companies like wont Space building constellations to monitor our climate, Firefly Aerospace making rocket launches more affordable, and eSpace tackling both satellite communications and the big problem of space debris.
And what's so cool is seeing how this whole ecosystem fits together. At the base, you have your component suppliers like Paris Defense, making really specialized optics and antennas. Then, companies like AEC Clyde Space take those parts and build advanced subsystems. Then, of course, you need a ride to space from launch providers like Firefly. And at the very top, you have mission integrators like RIFI, who use all that data and AI to give us insights on everything from climate change to global shipping. Every layer is a new opportunity.
Okay, so this is all really cool tech and a booming market, but let's connect it back down to Earth. Why does all this matter for us? Because the end goal here isn't just to build better satellites, it's to use them to solve some of our biggest problems right here at home.
Take a really concrete example, like national security. For a country like Indonesia, which has thousands of islands, patrolling its waters is a logistical nightmare. You have illegal fishing, smuggling, and these vessels that just turn off their trackers and go dark. But with advanced satellite surveillance, suddenly you have eyes in the sky. You can spot those dark ships, protect your resources, and secure your borders in a way that was totally impossible just a few years ago. And this impact goes way beyond Earth. When NASA landed the Perseverance rover on Mars, it wasn't just a case of cross your fingers and hope for the best. No way. As it was screaming through the Martian atmosphere, it had an AI co-pilot. It was taking pictures of the ground, comparing them to an onboard map in real time, and actively steering itself to a safe landing spot. The result? A pinpoint landing with just 40 meters of accuracy on another planet. Just let that sink in.
So where does all this go from here? What's next? Because believe me, this convergence of AI and space technology is really just getting warmed up. Let's look at the key trends that are going to define that next frontier. The really big shift, the next giant leap, is moving the thinking from the ground up to the satellite itself. Remember that data bottleneck, the coffee straw problem? This is the solution. Instead of trying to downlink a whole library of raw data, the onboard AI analyzes it right there in orbit and just sends back the important insights. This allows for true autonomy, satellites that can dodge debris, manage their own power, and even fix themselves, all without waiting for a command from Earth.
And that leaves us with one final, kind of mind-blowing thought. As these incredibly powerful AI systems start analyzing data in real time, right there in orbit, we have to ask, are we heading toward a future where the next great scientific discovery, a new weather pattern, a massive geological event, maybe even something from beyond our solar system, is made by a machine moments or even hours before any human even sees the data? That's the truly transformative potential of this